Let's take a look at this vectors question. So part A, find the value of k for which d, this vector which has an unknown in, is the midpoint of AC. Well, I'm going to draw a little diagram here to show what's going on. We've got an origin, which I'm going to label O. And the vector A is going to be 1 along and 2 up. Might look a little bit like that. And then this is point A. And then C is 7 along and 4 up. So maybe it's over here somewhere. And we can connect these, and then the midpoint is going to be here. Well, here's the thing, because these are position vectors, we can actually write down the coordinates of C. It's going to be 7, 4. The vector tells you a movement, but because we're starting from the origin, then we get this coordinate. And A is going to be 1, 2. And therefore, I want to find the midpoint, which is, in this case, D. Then it's just the midpoint of these two coordinates. And we can add them together, 8, and divide by 2 to give 4. Okay, that will be the middle value, the value that's halfway between 1 and 7, in fact. And then the halfway value between 2 and 4 is going to be 3. And so the vector d itself, if I was going to draw it, would then be equal to 4, 3. And so k is equal to 3. There's more complicated ways of doing this question. You could consider constructing the parallelogram formed by doing a plus c. Find a plus c and then find half of that because the diagonals bisect one another, but that's overcomplicating it really. Yeah, there's other methods as well, but anyway, whatever method you use, k is equal to 3. So I'm going to label this point D and look at part B, which is to investigate the vector AD. And that means I start at A and I get to D. So actually it's the same as doing AO plus OD, or minus OA plus OD, or D minus A. So, actually, it's worth knowing, understanding how to get this. But at the end of the day, we always take the second letter and subtract the first for these little position vectors. And we're interested in the magnitude of this vector equaling root 13. Well, first of all, I'm going to write D back as 4k. And then A is still 1, 2. So it is 3k minus 2. Okay, that's the vector AD. Therefore, the magnitude, actually, we can use Pythagoras' theorem because we're going 3 along and k minus 2 up or down. So we've got a right angled triangle, 3k minus 2. Okay, it might be going the other way, like I said, but in any case, AD squared is going to be 3 squared plus k minus 2 squared. But we're actually interested in the magnitude, so I need to take the square root and set it equal to root 13. So therefore I need to solve, I can actually get rid of the square root to be fair. I need to solve 9 plus k minus 2 squared equals 13. Now I could expand this quadratic out and solve it, but actually it's already in essentially completed square form. I've got the k inside a bracket squared. So k minus 2 squared is going to equal 4, and k minus 2 is then going to equal plus or minus the square root of 4, which is 2. When we get minus 2, I'm going to add 2 on. K is going to be 0. And when I have 2, I'm going to add 2 on and get 4. So it does say find the two values. Those are the two values. Right, finally, we have part C to this question. Here's is the main information in the question again. And then we're asked to find one value of C for which the 4 points form a trapezium. So there's more than one answer here because it depends how you form the trapezium. So I'm going to just look at one example. Okay, I've drawn a trapezium and I'm going to form it by going A, B, C, D. So make BC parallel to AD. Then we'll necessarily get a trapezium. Trapezium has at least one pair of sides with that are parallel. Generally it doesn't have two, but a square is an example of a trapezium, in fact, because it follows the same rules. If you work out the area of a square using the area of a trapezium formula, you'll get the right area. So it must be that square is a trapezium, but we're working at a more general level here. We just want to get one pair of parallel sides. Now, in this 2D setting, again, the easiest way of doing it is to consider these as coordinates. So 7, 4, 4K, 1, 2, and 3, 5. So then the gradient of BC, I know it looks like it's 0 here, but I've not drawn it in the correct orientation, is going to equal, I know I've not drawn it accurately because the 5 is over here. It doesn't actually matter. 4 minus 5. Okay, as long as I do y2 minus y1 over x2 minus x1, I'm consistent. And then for AD, oh, by the way, this is going to be minus 1 over 4. Then for AD, it's going to be k minus 2 over 4 minus 1. Okay, so I'm going to set them equal. So k minus 2 over 3 is equal to minus 1 over 4. Therefore, k minus 2 is minus 3 over 4. And k is going to equal 1 1/4 or 5 over 4. So that is the solid method. If you'd chosen some of the other sides to be parallel, then you could have got these answers. So, if you didn't get 5 over 4, it might be right. 16 over 3 is an alternative, or minus a half. And it will all depend on which pair of sides you are making parallel. Now, I want to show you a second method for doing this question. It's actually the way that I did it. The pros are that it's a vector method that would extend well to 3 dimensions, which you'll do 3-dimensional vectors in the second year A level. Cons are this, yeah, it's a little bit more complicated than just using the gradient. So I'm going to do the same kind of setup. I'm going to construct my trapezium. And I'm going to assume BC and AC are parallel. And then I'm going to find the vector BC. Now I've talked about how we find this previously, so it's just C minus B so it's going to be 4 minus 1. AD is similar. So I get 3 and k minus 2. Now we're going to assume they're parallel to give a trapezium. So if the parallel, one must be a multiple of the other one. Okay, because they're going in the same direction. And therefore, it must be that 3k minus 2 is equal to some constant, I might call it p, times 4 minus 1. And we've got that 3 will equal 4p, because it must be that the x coefficients are equal. Therefore, p is going to be 3 over 4. And therefore, k minus 2 is going to equal 3 over 4 times minus 1. This is going to be minus 3 over 4. We're actually back to where we were with the gradient method. K is going to be 5 over 4. And again, you could use this method for different pairs of parallel sides to get all those different answers. So I think both methods are worth understanding. The gradient method has worked well in this question for part A. We went away from it in B because we're using Pythagoras. In C, it was effective. This is a more general method, quite a powerful method, I think, that can, also works.